Hello students, welcome to the first lecture on the lecture series on permutation and combination. So in this lecture, we will learn what permutation is, what combination is, and what are the relation among permutation and combination. Okay, how we can actually physically interpret these terms. Okay, so in this lecture, we will be covering all the theory and basic concepts for the topic permutation and combination. And if time permits, we will cover some types of problems that are usually being asked on this topic on various competitive exams. So let's go forward and start this lecture. Okay, so we'll be covering concept and some types of problems if time permits. Okay, on permutation and combination. So let's go from the introduction. Okay, so permutation is what? It is actually a fundamental counting concept. Okay, that is used in combinatorics. Okay, that deals with arranging or selecting objects in a specific order. Okay, so this is the point that actually makes it distinct from combinations. Okay, so permutation is a fundamental concept in combinatorics that deals with arranging or selecting objects in a specific order. Okay, so it is basically widely used in various mathematical and real life scenarios, including probability. Okay, cryptography, data analysis. So permutation is the order of arrangement is crucial. Okay, in permutation, the order of arrangement is crucial. Okay, it matters. Okay, each arrangement is considered as unique. Okay, so basically you have three girls. Okay, Meena, Reena, and Tina. Okay, so how you can make them sit in a row? Okay, so a row must be something like this where three seats are there. This is seat 1, seat 2, and seat 3, right? So either Meena can sit here, right, or Reena can sit here, and then Tina can sit here. Or what can happen? Or it can also happen Reena can sit here, Meena can sit here, Tina can sit here, right? Or what can happen? Meena can sit here, Tina can sit here, then Reena can sit here. Okay, these kind of scenarios. Okay, there will be actually total 6 kind of scenarios in which Meena, Reena, and Tina can be actually seated. We'll learn how actually we can evaluate those things. Okay, using the concept of permutation and combination. Basically, we'll be using permutation because in permutation actually the order matters. Okay, so the number of permutation of a set of objects is determined by the factorial function. Okay, what is factorial function? So function is what? It takes some value and it gives something else, right? So f takes this and gives this. Okay, this is symbolically what I mean to say. Okay, so what is factorial function? So factorial function is usually defined on the set of what? Positive integers. So that is natural numbers actually. So n that is equal to what? 0, 1, 2, 3, and so on, right? So n factorial is what? Where n belonging to natural number n. Okay, so n factorial is nothing but n factorial is equal to n into n minus 1 into n minus 2 and so on into multiply by 2 into 1. Okay, such that so n is greater than equal to 1. Okay, so n is actually greater than 1. Okay, so this formula, but n 1 factorial is equal to what? 1 factorial is equal to 1, and 0 factorial is also defined as 1. Okay, this is something as a fact you have to remember. Okay, you can't use this formula right here. It is a fact that you need to consider. Okay, this will be considered as a fact. So understanding permutations is essential for solving problems related to arranging people in a line, selecting a committee, arranging letters in a word, and many other situations involving arrangements and selections. Okay, so concepts. It is denoted by NPR or PNR. Okay, and calculated as n factorial by n minus r factorial, where n is the total number of objects and r is the number of objects to be selected and arranged in a particular order. Okay, so it is denoted by what? NPR or PNR, and calculated as what? N factorial by n minus r factorial, where n is the total number of objects and r is the number of objects to be selected and arranged in a particular order. Okay, so let's see the formulas and properties. So permutation of n objects taken r at a time. Okay, so npr is equal to what? N factorial by n minus r factorial. So permutation of n objects in a row, so n factorial. So the number of permutations when you have n objects with p identical items in one type and q identical items of the another type. okay, is what? N factorial by n minus r factorial. Okay. So permutation of n objects taken r at a time is what? NPR, that is equal to n factorial by n minus r factorial. Permutation of n objects in a row is what? N factorial. So the number of permutations when you have n objects where p identical items of one type and q identical items of other type is actually, okay, repeated, will be, this is not correct, this will be actually n factorial by p factorial into q factorial. Okay, p identical items and of one type and q identical of the another type. Okay, this will be this formula. Okay, this is actually wrong. Okay, so n factorial by p factorial into q factorial will be the answer. Okay, for the third type. So let's see the formula and properties some other type. Okay, so number of permutations when all the objects are alike. So in this case, the number of permutation is simply 1 because all of them are actually alike. Okay, so circular permutation. Okay, so this kind of concept will actually be used in what? The kind of questions where you are asked actually to say in how many way we can actually arrange some people to sit in a circular chair, circular table, or a committee where you have to sit in a circular manner. Okay, so the number of circular permutation of n different objects taking all at a time is what? N minus 1 factorial. Okay, so what is linear permutation? So the number of linear permutations of n objects is n factorial. Okay, so the number of linear permutation of n objects is n factorial. So let's try to see formulas and properties. Okay, so permutation with repetition. Okay, so basically when n objects are taken r at a time with repetition. Okay, so some are taken with repetition. So the number of permutation is given by n raised to power r. Okay, so it will be n power r. Okay, so if you have n objects, let's say you have 3 coins. Okay, and taken r at a time. So you are taking 2 coins at once. Okay, with repetition. Okay, then the number of permutation is given by what? N power r. Then in how many way can you pick? Okay, 2 coins. Okay, for r times. So it will be what? 2 power r, right? So that is how 3 power r actually 3 power. Okay, because always you have 3 options there. Okay, so n power r will be the answer. So number of ways to arrange identical objects. So if there are n objects, okay, number of objects here is n, out of which p objects are identical. Okay, q objects are identical, and so on. Then the number of permutation is given by what? N factorial by p factorial into q factorial, and all the kind of repeated types. Okay, with the number of types, with the number of repetition factorial multiplied in the denominator with p factorial and q factorial and so on. Okay, here you have to fill in. So property of multiplication. So if operation can be performed in m ways, and for each of these the second operation can be performed in n ways, then both the operations can actually be performed in m into n ways. Okay, so let's try to see the type of questions that are usually being asked on permutation on various competitive exams. Okay, so basically there are 10 types of questions. Okay, so the first type is finding the number of permutation of a set of objects taken r at a time. Okay, so you have actually you have to calculate the number of permutations, okay, of a subject of a set of objects. Okay, let's say it will be n set of objects. Okay, n number of objects taken r at a time. Okay, we are taking r each time. Okay, so finding the number of permutation when some objects are like and others are different. Okay, when two are alike and others are different, and so on. Okay, finding the number of permutation when all objects are alike, and circular permutations. Finding the number of linear permutations when some objects are actually identical. Permutations with repetition. Interchangeability of objects. Solving word problems that actually involve arrangements and selections of objects. Okay. Finding the probability of certain outcomes in permutation problems. Okay, so applying permutation concepts to solve real life problems such as seating arrangements, committee formations, etc. Okay, these kind of questions are usually asked in various competitive exams on the topic permutation. So let's try to see what each kind of question, okay, literal physical question about those kind of types. Okay, so let's start with the first type. Okay, finding the number of permutation of a set of objects taken r at a time. Okay, how many different ways can you arrange the letters A, B, C, D to form a 3-letter word? Okay, so you need to form a 3-letter word. Okay, So for the first place, you have 4 choice, right? For the second place, you already have 4 choice. And for the third place, you have already 4 choice. So it will be equal to what? So this choice will be multiplied. Okay. So 4 into 4 into that will be equal to what? 4 power 3 is equal to 64. Okay. So basically, if there are n set of objects, and you want to pick 3 at a time, or r at a time. Okay. So let's see, it will be, let's say total r boxes are there. Okay. So it will be n power r. Here n is what? N is 4. Like number of objects from which I can actually choose is 4. And how many numbers I want to choose? I want to choose only 3. Okay. So 3 letters I want to choose. So that is why it was 4 power 3. That is how we will need n power r if we have n set of objects and we want to choose r at a time. Okay. So to find the number of permutation, we use the formula permutation, that is n objects taken r at a time, which is given by npr, that is n minus n by r factorial. In this case, n is equal to what? 4 and r is equal to 3. Okay. So number of permutation will be 4p3. Okay. That is 4 factorial by 4 minus 3 factorial is equal to 4 into 3 into 2 is equal to actually 24. Okay. So there are 24 ways. Okay. 24 different ways to arrange the letters to form 3-letter word. Okay. So type of questions. Okay. Finding the number of permutation when some objects are alike and others are different. Okay. In how many ways can the letters of the word Mississippi be arranged? Okay. So the word Mississippi has 11 letters, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it will be what? 11 factorial by what? How many type of letters are there? 1, 2, 3, and 4, right? And how many are? So M is repeated only once. I is repeated what? 1, 2, 3, 4. Repeated 4 times. S is repeated 4. And I is repeated that once. And P is repeated twice. Okay, so it will be 1 factorial into 4 factorial into 4 factorial into 2 factorial, right? So 11 factorial by 4 factorial into 2 factorial into 4 factorial, it will be equal to 34,650. So the number of total permutations will be 34,650. So there are 34,650 different ways to arrange the letters of the word Mississippi. Okay, finding the number of permutations when all objects are actually alike. So how many different ways can you arrange the letters of the word book? So it will be what? 4 factorial by 2 factorial, because number of letters is equal to 4, but number of distinct letters is equal to 3. So it will be what? 4 factorial by 2 factorial. Okay. So that will be equal to 4 into 3. That is equal to 12. Okay. In 12 different ways, we can actually arrange the letters BOOK, book. So the book has what? 4 letters and O is repeated 2 times. Since all the letters are alike, there is only one way to arrange them. Okay. So actually it won't be the correct answer. The correct answer will be this. That is 4 factorial by 2 factorial is equal to 4 into 3 is equal to 12. So what is circular permutation? So finding the number of ways objects can be arranged in a circle. Okay. So in how many ways can 4 people be seated around a circular table? Okay. We know that for circular permutations, the number of arrangements is what? N minus 1 factorial. In this case, n is equal to actually 4. So number of circular permutation will be n minus 1 factorial is equal to 3 factorial is equal to 6. So there are 6 different ways that 4 people can be seated around a circular table. Okay. So find the number of linear permutations when some objects are actually identical. Okay. How many different arrangements can be made using the letters of the word apple? So here, as you can see, number of letters is equal to 1, 2, 3, 4, 5. Right. So we have 5 letters here, and so it will be 5 factorial by. So how many letters are there? 1, 2, 3, 4. Only 4. Right. So only P is repeated twice, so it will be 2 factorial. So it will be 5 into 4 into 3. That will be equal to 20 into 3 is equal to 60. So 60 will be the correct answer. Okay. So the word apple has 5 letters with P repeated 2 times. Number of permutations is equal to 5 factorial by 2 factorial is equal to 60. Okay. So type of questions. So permutations with repetition. So find the number of ways to arrange objects with repetition. Okay, in how many ways can you arrange the letters of the word banana? So here you can see number of letters is equal to what? 1, 2, 3, 4, 5, 6. So 6 letters are there, right? And how many are repeated there? A is repeated, N is repeated, right? So 1, 2, 3, 4, 5, 6. So 6 factorial. By what? N is repeated twice, so 2 factorial. A is repeated thrice, so 3 factorial. B is repeated once, so 1 factorial. So it will be equal to what? 6 into 5 into 4 by 2. That will be equal to 6 into 5 into 2. That is equal to 60. Okay. There are 60 ways to arrange banana. So the word banana has what? 6 letters. Okay. A repeated thrice and N repeated twice. So 6 factorial by 3 factorial into 2 factorial, that will be equal to 720 by 12, that is equal to 60. Okay. So there are actually 60 different ways to arrange the letters of the word banana. So let's see the seventh type of question, that is interchangeability of objects. Okay. So finding the number of permutations when objects of different types are actually interchangeable. Okay. In how many ways can you arrange 3 red balls and 2 green balls in a row? Okay, if you have 3 red balls and 2 green balls, okay, since the red balls are interchangeable among themselves and the green balls are interchangeable among themselves, the number of permutation is given by 5 factorial by 3 factorial into 2 factorial is equal to 10. So there are 10 different ways to arrange the red and green balls in a row. Okay, so in a row there are actually 10 different ways. So solving word problems that involve arrangements and selection of objects. So a committee of 3 members is to be formed from a group of 8 members or 8 people. Okay. So in how many ways can this be done? Okay. So basically you have 8 people, and for 3 members you have, once you pick one, you can't actually replace them, right? Because they need to be there. Okay. Otherwise it won't be a 3-member committee. Okay. So you have 8 people and you want to pick 3. Okay, for this you have 8 choice. For this, since you have already picked one, you have 7 choice. And for this you will have 6 choice. So it will be equal to 8 into 7 is equal to 56 into 6. Okay, whatever it is, it will be 336. Okay, so this much amount of ways to select 3 people out of 8 people to form a committee of 3 members. Okay, or you can also use NCR. Okay, that is n factorial by r factorial into n minus r factorial, that is equal to what? 8 factorial by r factorial is what? 3 factorial into 5 factorial. So it will be 8 into 7 into 6 by 3 into 2. So it will be equal to this. Okay, so this will be actually equal to this much. Okay, so it will be equal to 56. Okay, there are 56 ways to make it happen. So n is equal to 8, so 56 will be the correct answer. Okay, so there are actually 56 different ways to form a committee of 3 members. So finding the probability of certain outcomes in permutation problems. Okay, so a 6-sided fair die is rolled twice. What is the probability of getting a different number on each roll? Okay, total possible outcomes is equal to 6 into 6 is equal to 36 as 2 dice are rolled. So number of favorable outcomes, that is different number on each roll, is equal to what? 6 into 5 is equal to 30, right? So probability is equal to number of favorable outcomes by total possible outcomes. 30 by 36, that will be actually equal to 5 by 6. So the probability of getting a different number on each roll is what? 5 by 6. So the 10th kind of question, that is applying permutation concepts to solve real life problems such as seating arrangements, committee formation, etc. Okay, so in how many ways can 5 boys and 5 girls be seated in a row such that no 2 boys or girls are sitting together? Okay, so to solve this problem, we can use the concept of alternate arrangements. Okay, first arrange the 5 boys in a row, which can be done in what? 5 factorial ways, right? So then what you do, you arrange the 5 girls in 6 vacant places between the boys, which can be done in 6 factorial ways. So total number of ways is equal to 5 factorial into 6 factorial is equal to what? 120 into 720, 86,400. So there are actually 86,400 different ways the 5 boys and 5 girls can be seated in a row without any 2 boys or girls sitting together. Okay, so I feel that's enough for today. Thank you. Okay, in the upcoming lecture we'll be doing some exercise problems, okay, on the same. Thank you.